This project is implementation of UART receiver on Basys-3 board. A UART is a universal asynchronous receiver transmitter, which is a hardware communication protocol used for serial data communication. The transmitter will transmit from one device and the receiver receives the data in another device. In this project, we intend to implement the receiver part of UART, in which the FPGA board is deployed to work as a receiver and the PC acts like a transmitter which will send the data bits from the PC to the receiver. The UART transmitter and receiver must transmit and receive at the same known speed. If the receiver's baud rate is not exactly the same, then it might misinterpret bits and cause data corruption. In this project, we use the baud rate of 9600. This is the UART frame format in which the start bit is of 1 bit and it is usually 0. This is the 8-bit data bits, 1 parity bit which is optional and 1 stop bit which is usually 1. This is the algorithmic state machine of UART receiver. It will start and remain in the idle position. When the first start bit comes, it will check whether it is 0 or 1. If it is 1, it will remain in the idle state. If it is 0, then it will start receiving the number of bits. Then it will count whether the number of bits is 10 or not. 1 for the start bit, 8 bits for the data bits and 1 for the stop bit. If the count is not equal to 10, then it will keep on receiving the bits. If the count is equal to 10, then all the bits will be received and it will go in the done state. This is the data path components of UART receiver. Bit counter. Bit counter is used to count the number of bits received by the receiver, that is start bit, data bits and stop bit. If the number of bits is 10, then bit index is 1 and it means that data has been successfully received by the receiver. Wait counter. Wait counter is used to count the number of cycles to sample 1 bit corresponding to the clock of the receiver. The next data path component is serial in parallel out shift register. Shift register is used to store and shift the start bit, data bits and stop bit. When the bit index is high, that is all the bits have been received, then load the received data load Rx is high and 8 bits data will be loaded out. The point to note here is that the LSB bit is shifted in shift register first, then the other bits follows. Sampling data at the bit pulse center. In UART receiver, bits are sampled at the midpoint of each bit period called the bit pulse. As you can see in this figure, the bits are sampled at the midpoint of the bit pulse center. It is done to maximize reliability and minimize errors caused by clock mismatch, noise or jitter. Midpoint will be the most stable point to sample a bit. Noise, glitches or transitions are more likely to occur at the edges of a bit period. Sampling at the center avoids these edge effects. Even if there is a small clock drift between transmitter and receiver, the midpoint remains reliable over a few bits. This is the data path controller and top module of our UART receiver. In the top module, clock, reset and Rx signals will be sent. Rx signal is basically the start bit, 8 bits data bits and the stop bit which will be fed sequentially to the UART receiver. When all the bits have been received, the Rx done signal will be high and the 8 bits data bits will be shown in my LED. So this is the data path and controller. Rx is sent and from this data path the bit index will be sent to the controller and the wait counter will be sent to the controller. From the controller the wait count enable signals, wait count reset signal, bit count enable, load shift register, shift right of the shift register, and loading of the RX signals will be sent back to the data path, and all the 8 bits data will be shown in the LED. And finally, the RX done signal is also high. This is the controller of UART receiver. When it is reset, then it will remain in the idle state. When the first start bit comes, that is Rx equal to 0, it will go to the next state, that is the synchronization state. When the start bit is 1, it will remain in the idle state. In the synchronization state, wait counter enable is 1. So in this project, the clock frequency is 100 MHz, which means this is the clock frequency of the UART receiver. In our project, the UART receiver is the FPGA Basys-3 clock, which is 100 MHz. Baud rate 9600, bit duration count F clock by baud rate. Bit duration count is the number of cycles required to sample one bit corresponding to the clock of the receiver. So when the first start bit comes, this wait counter enable has to count till BTC by 2, and for the next bits it has to count till BTC. So when the wait counter is equal to BTC by 2 minus 1, it will go to the next state, that is the receive state. In receive state, the wait counter is reset, bit counter enable is 1, load SR is 1. Load SR1 means that the data has been loaded in the shift register. Bit counter enable will count the number of bits in the shift register. Then from the receive state, it will go to the check state at the next positive edge of the clock. In the check state, shift right is high, which means data that was loaded in the shift register will be shifted right in the check state. Then it will check if the bit index is 0 or 1. Bit index 0 or 1 means bit index 1 means that the number of bits is 10. Bit index 0 means that the number of bits received in the shift register is not equal to 10. If the number of bits is not equal to 10, bit index is 0, then it will go to the R wait state. In the R wait state, wait counter enable will be 1 and it will wait for the next bit to come. This WC will be equal to BTC minus 2. Then again it will go to the receive state and the next bit will be received in this state. Then it will again check whether the number of bits is 10 or not. This loop will go on, and in this loop continuously in the shift register data will be loaded and shifted, loaded and shifted. When finally the number of bits becomes 10 and the bit index becomes 1, from the check state it will transition to the done state. Here Rx done will be high, which means that all the bits have been received. Load Rx will be high, which means that the data which was loaded in the shift register will be loaded out and then it will remain in the done state. Then if again the start bit comes for the next set of datas and Rx is 0, it will again go to the synchronization state and this FSM will keep on working. And if the start bit is 1, it will remain in this state. Next, I am going to show the demo of the UART receiver which was implemented in our project. When I am pressing A, the data is transmitted. The Rx done is high and the data transmitted is 01000001. When I am pressing B, the data transmitted is 01000010. When I am pressing C, the data transmitted is 01000011. D, the data transmitted is 01000100. For H,
is this.